Hello, everyone. I'm Zhang Mengmeng from Group 7. I will represent my group to show the demo process here. First, we do startup options. And then we start the Wireshark. And we type OpenFlow here. Now we start to capture. We found that there is no packages being captured. Okay, we just close it. And then we do the interact with host and switches and just and now we have start a minimal topology. And now we open this one. We found this has been connected. And then we capture the packages. You could see that the packages start to be captured here. Okay, now we just continue. Enter help here. Should we get this? And then we enter nodes here. We get all the nodes. We enter net here, and we get all the links. We type dump here, and we got the dump information about all the nodes. And you could see that the switches and the one switch and two hosts listed here. And if the first string typed into the mininet CLI is a host switch or controller name, the command is executed on that node. Run the command on the host process. We put here if config. If config. Yeah, we could see the host and lookback interfaces here, and in the contrast, when we type this if config, that's one if config here, that this will show the switch interfaces and the VMs connected out. And for another examples here, and when we put h1 ps a here, we got this. When we put s1 ps here, got this. And we have done the test now. And next is about the test connectivity between the hosts. And now verify that we can ping from host 0 to host 1. H1 ping. And then we repeat the last ping. We found that we could see a much lower ping time for a second try. And now, and much more easier way to run this test is to test PL here, and we got this. So now we're going to run a simple web server and client here. We put h1 Python 3. So and then h2. Yeah, and finally we put, Python. Got this. So we have run a simple web server and client here. Now we just exit from this. And now we go to the part 2, advanced startup options, and just we have to run the regression test. In here. This command creates a minimal topology, started up the OpenFlow reference controller, run an all pairs spin test, and tore down both the topology and the controller. Another useful test is iperf. Let's type iperf here and just give about 10 seconds to complete it. And this command creates the same mininet, run an iperf serve on one host and an iperf client on the second host, and parsed the bandwidth achieved. Next, we have to change topology size and type. Here. We got this here. It is about single switch connected to 2 hosts. We could change a different tuple with this type and pass parameter for that topology's creation. We just to verify this, get this. And another example. Here, this is an example with one single switch connected to 2 hosts. And now we do another example with a linear topology. Let's do this. Linear for, and this is with a linear topography, and each switch has 1 host and all switches connected in a line. You can see the result tend to be this. See that the parameterized topologies are one of the Minilight's most useful and powerful features. And next we'll do the link variation. Let's do link. Delay here. Let's do 10 seconds. And Minilight 2.0 allows us to set link parameters. And this can even be set automatically from the command line here. Just going on. Oh no. Yeah, just wait. And which one? Two. Here, if the delay for each link is 10 ms, the round trip time RTT should be about 40 milliseconds. Since the ICMP request traverses 2 links, one to the switch and one to the destination, and the ICMP reply traverses 2 links coming back. So we got the results 10 and the 40. Here, now we just finished the link variation, and next we go to the adjustable verbosity. So do mn, and what do we have here? Show that the default verbosity level is info. Okay, what do wrong here? We have to exit, sorry. I see some trouble here. Yeah, and then we type. See? No. Anyway. Well, yeah. And lots of etc. details has been printed out here. And after the adjustable verbosity here in the exit. Now we try output. What do we have here? Nothing. We exit. Okay. Outside the CLI, other verbosity levels can be used, such as warning, which is used with the regression test to hide unneeded function output. And about the custom topologies, yeah. We use Python API to, in that custom topology can be easily defined as well. So when the custom minimized file is provided, it can be add new topologies, switch type, and test to command line, for example. And when we start here, no, sorry. And we enter this because it's just work out. Waiting for connect. Yes, it is for the Python API. And next we look at the ID equals to MAC. And each one if config because this the IMAC option is super useful and sets the host MAC and IP address to the small, unique, easy to read IDs. And then after this, we do no, we have to exit here. We got this. In the contrast, the MACs for switch data ports reported by Linux will remain random. This because you can assign a MAC to a data port using the OpenFlow, as noted in the FAQ. This is a somewhat subtle point which you can probably ignore for now. About the external display, we have here and we have this. So for after a second, the action will pop up. Yeah, just okay. Fast. And when we put this thing here, so we can see that nothing here, nothing print out here. And we go to this page, host one. When we run this thing, ping, here, we can see that, and then we go back to here. We do this again. Now we can see that multiple flow entries now. Alternatively, and generally more convenient, we could use the dpct1 command built into the mainline CLI without needing any xterms or manually specifying the IP and port switch. Okay, we just exit. here. And for other switch tabs, and then we use sudo imn switch user test iperf. Note that much lower TCP iperf reported bandwidth compared to that seen earlier with the kernel switch. Okay, on the other hand, if we do this, if we test switch iperf here, another example is Open vSwitch, which comes pre-installed on the Mininet VM. The iperf reported TCP bandwidth should be similar to the OpenFlow kernel module and possibly be faster. And the next step is about the Mininet benchmark. Sudo admin test. Now here, to record the time and to set up tear down a topology, just use the test now. It is about the Mininet benchmark. And then next, sudo admin namespace. We insert. And by default, the hosts are put in their own namespace, while switches and their controllers are in the root namespace. To put switches in their own namespace, past this option, we can get this. And then instead using lookback, the switches will talk to the controller through a separately bridged control connection. By itself, the option is not terribly useful, but it does provide an example of how to isolate different switches. Now we get it here. Okay, the path-free Mininet command line interface, the display option, just sudo imn we got thing here, help here, got this. Okay, about the passing interpreter, we put as the Mininet CLI, we just run this UI. Hello. That's what. World. Okay. Maybe it should be. Not so familiar with this. Okay, just show hello world here, and the string just be printed next of this command, and when we put py course and just print accessible local variables, and next print py dir and s1. Okay. Now we get about this things, the methods and properties available for a node here. And when we put py help, what will happen here? Here we can read the online documents for methods available on the node by using this help function. Now, maybe we can exit. Okay, no, we have one thing more to do. Py h1 ip, and what's this? It's also evaluate methods of variables. Okay, about the link up and link down. Link up and link down. Put link s1 h1 up. No, down. and up. And we print the X term H1, H2. Yeah, it just show these things here. X term show here. And leave it. Okay. Okay, thank you for watching.